Hello students, today using the Sharp Comet CS2850 desktop electronic printing calculator, I'm going to demonstrate home row keys, touch addition of whole numbers, addition and subtraction, and also the subtotal and total keys. So one of the first things I want to do before doing any problem on the calculator is to make sure that any functions that I don't intend to use are disengaged. So this double dot position means that that function is in neutral or not being used. So I'm going to make sure that all these function keys are not in use, they're in the double dot position. Then the other thing I want to do is make sure that my calculator is set to print. In this case, this is where I turn the print on and off, so I'm going to make sure that that's engaged. This rounding function we won't be using, so we want it to be in that middle 5/4 position. I'm going to be working with whole numbers initially, so I'm going to go ahead and set that decimal selector at 0 because these are whole numbers in the problems we'll be doing. So the home row keys indicate where your fingers should be placed on the keypad. We use the index finger for the 4 key, and we would reach up to the 7 and down to the 1 with that index finger. The middle finger rests on the 5 key, reaching up for the 8, down for the 2, and then the ring finger sits on the 6 key, reaches up for the 9, down for the 3. If it's a 0, then we'll use our thumb, and our pinky we use to put in a positive number or a negative number. We would reach up there. Now sometimes I reach over with my ring finger as well, and you'll just have to see in terms of what your comfort level is. But the idea is that this is home row, this is where our fingers ordinarily rest, and we move them to reach the keys that we need. So you'll notice that there's a dot here on the 5, and that helps you know by touch that you're on home row for placement. So let's key in the demonstration problem on page 3. This is a demonstration problem of addition of whole numbers. So I'm going to first clear my calculator to make sure nothing is in there and tear off my tape. We'll start with a fresh tape. All right, so we're on page 3, keying the demonstration problem. 4, 5, 6, 44, 45, 46, 55, 56, 456. Now notice that I can see my total here on the display, but to get it to print on the tape, I actually need to reach over here and hit this total button. Now the total displays on the tape as well. All right, let's move on, and I'd like to show you the demonstration problem on page 10. In this demonstration problem, we're going to do touch addition and subtraction of whole numbers. Now, something that I want to point out at this point that is a big difference between 10 key calculators and pocket calculators, and that is that on the 10 key, you key in the number and then a positive sign or a negative sign according to whether it's a positive number or a negative number. So in keying the demonstration problem on page 10, notice that the first number, 485, is a positive number. So we key it in by pressing the plus key. The next number, 365, is a negative number. Now I can reach over here, or I could have done that with my pinky. So now we've got a positive number and a negative number. The third number is another positive one, so we key in 5, 8, 9, positive, 3, 5, 0. Okay, I should have reached with my thumb there. Negative, 7, 7, 5, positive, 9, 8, 0, negative, 1, 5, 0, positive, 1, 2, 3, negative, and then we hit the total key. So notice that our tape shows these negative numbers in red. So this is simply combining these positive numbers in black with these negative numbers in red, or doing addition and subtraction with the 10-key calculator. And here's our total. Let's take a look at page 12 for a moment. I'd like to do the demonstration problem where we end up with a negative balance. So this is page 12. To the left, you'll notice that the problem is a positive 525 getting combined with a negative 750, which produces a negative result. The negative result shows up by the answer or the total appearing in red, because the negative component of the problem was greater than the positive component. The end result is a negative number. Let's take a look at page 13. And we're going to do a demonstration problem where we use the subtotal and the total keys. So the subtotal key is this key right here on the Sharp calculator. If you're using a different calculator, obviously you'll need to get your manual out and get familiar with where these functions are on the calculator that you're using. But on this particular calculator, this key would represent the subtotal key. So I'm going to do the demonstration problem on page 13, which incidentally has an error in it. So let's go through it so that I can point out to you the error that is there in the text, and we can also go through the demonstration. So the problem we're going to do, we are going to first key in 30, okay? 30 twice. Now, I keyed it in, and because it is a repetition of that same number, I could have just pressed the plus key. So instead of keying 30 in twice, I could have keyed it in once, hit the plus key twice, and it would have entered it. So let me just clear that. This CE key, this is my clear key. If I press it, it wipes everything off the display and takes me back to 0. Let's see what would happen if I press this back arrow. Oh, notice that that eliminates the 0, but not the 3. So if I had keyed in 30 and I meant to key in 33, I could just use that back key, go back one digit, replace it, and have made that correction. If I want to wipe the entire display clean, it's CE. So we are keying in 30 and 30. Now notice that the next number is negative. So I'm going to key in 25 and hit the minus sign. And then the next number, 35, that's a plus. Now, that next line, I want to show a subtotal. In other words, what is my total so far? So I'm going to hit this subtotal key here. And notice that that diamond shape shows up on the tape. That's the indication that that is your subtotal so far. Notice that your textbook shows that subtotal as 193. That is not correct. I'm going to continue the problem. The next two numbers are 45 negative. Now because I've already keyed in 45 and a negative, because the next number is the same number, I can just hit that minus key and it will enter it a second time. Now I want the total. So I'm going to press my total key here. So let's take a close-up look at this tape. Notice that I've combined positive and negative numbers and gotten a subtotal. And I can see it's a subtotal because I see that diamond shape. Then I keyed in the next two numbers, press the total button. So 20, which is negative number, is the answer to that problem. Hello students. In this video, we are going to take a look at the inventory card demonstration problem on page 14 of your text. Inventory cards are used to keep track of the inventory or merchandise that you have in stock. They include adding quantities as they're received and subtracting quantities as they're sold, so that at any point in time the balance shows the items that are actually in stock on any given day. So using the inventory card demonstration problem on page 14, we're going to assume that on the 20th of January, we receive some inventory in the amount of $200. So, or I should say 200 items. So I'm going to key in 200 to represent the items received. Then on the 22nd of January, we sold 47 items. So I'm going to key in 47 and minus because our inventory was reduced by that amount. Now notice that on the display, the new subtotal of 153 is what is displayed. Those are the number of items I have left in stock. Now, if I want that subtotal to actually appear on my tape as well as the display, in addition, what I'm going to have to do is hit this subtotal key over here. So with your thumb or index finger, now that subtotal appears on the tape. On the 28th of January, we sold another 55 items. So I'm going to key in 55 with the negative and hit my subtotal key so that my new item count of 98 shows on the tape. On the 2nd of February, I sold another 38 items, so I'll key that in and the minus sign. On the 9th of February, I received 150 items into stock, so I'm going to key in 150 and the plus key because I received those. On that same date, I sold 35, so I'm going to key in 35 and the minus. Now, oops, I forgot to hit my subtotal in between there. I'm going to hit it now so that I can see how many items I actually have in stock. Then on the 11th of February, I sold another 60, so 60 and a minus. On the 16th of February, I sold another 58, key that in as a minus, and now I'm going to go ahead and, oh, again, I forgot to press my subtotal between those. So you see what happens? When you do that, while the subtotal appeared here, it's not on my tape. The problem is that that makes it difficult to audit this inventory card because I don't have those subtotals all along the way. So I'm going to go ahead and total this, and you will notice that the totals that are shown in the balance of the illustrated inventory card are incorrect. Let's key this problem one more time, remembering to hit that subtotal key between each one. So I'm going to tear off this tape and we're going to try this one more time. So on the 20th of January, we received 200 items. So I'm going to key that in, and that becomes the balance. On the 22nd, I sold 47. Subtract that, hit the subtotal. On the 28th, sold 55. Subtract that, hit the subtotal. On the 2nd, sold another 38. Subtract, subtotal. On the 9th, I received 150. So I'm going to see what the subtotal is after that, and then I sold 35, subtotal again. Then on the 11th, sold another 60, subtotal. On the 16th, sold another 58, and now what is my grand total? Now let's take this tape and let's compare this to the inventory card. You can see that the balance of 153 agrees with the inventory card. The balance of 99 agrees to the inventory card. But right here, we see that the inventory card has 66 and the correct answer is 60. So that inventory card from that point down is incorrect. And we'll have to insert these totals of 60, 175, 115, and 57 as the correct numbers. So we're using touch addition and subtraction to help us to verify the accuracy of the inventory card. Hello students, in this video I'm going to demonstrate the use of the grand total key in doing cross-footing for checking your own work. On page 17, there's a demonstration problem where we want to be adding the rows as well as columns of numbers. Let me show you how we can use the grand total function to cross-foot this problem and assure ourselves that we have the correct totals. Here's our functions here with this particular calculator. The grand total function is located here. I'm going to engage it. So I'm going to move the blue selector up to the GT position. So now I'm going to do the demonstration problem on page 17, and I'm going to first add the rows and then the columns. These are whole numbers, so I'm going to leave my decimal selector right there at 0. So I'm going to key in the first row, and it's total. Notice that when I hit the total key, in addition to that asterisk that appears, there's also a little plus sign next to it. That means that that total is going to get combined in with the grand total. Let's do the next row. 754968, total key. 696875, total key. Now, each of those totals, the 199, 192, and 212, is going to go into the grand total. When I hit this blue grand total key, it will combine them. So we should also see a little G on the tape. That shows you that that's the grand total. So the grand total that you should be seeing on your tape is 603. Now I'm going to add the columns. When I hit the grand total key here, not only did it give me the grand total, but it cleared the memory. So I can go ahead and start keying those columns without hitting the clear button. So I'm going to key the first column, hit the total, second column, hit the total, third column, hit the total, now hit the blue grand total key. And you should have 603. So take a look at our tape. You can see that the grand total function is engaged because we're seeing this asterisk as well as the plus sign after it. So all those went into this grand total. Now, for the columns, these numbers were all combined to get this grand total. And look at how the grand totals are the same. That's exactly what we want to see. That verifies our accuracy. That is cross-footing to proof your own work using the grand total key. Hi students. This video lesson today is focused on using the add mode function on the calculator. Engaging the add mode function is like telling the calculator to put a decimal point in the number. And the add mode is located, oops, I'm going to clear my calculator, is located on the sharp calculator here. We're going to put it in the up position where you see the A slash and then a little plus sign. That engages the add mode. So that is like giving the calculator the instruction of put a decimal in this number for me. And then we have to also tell it where to put the decimal. So this decimal point selector here will tell it where to put it. I am going to select the decimal selector on 2, or put the decimal selector on 2. And we're going to do the demonstration problem on page 20. We're going to key in those numbers and notice that they are not all whole numbers, and that's why we're using the decimal point selector. We are going to combine both some positive and negative numbers that have decimals in them or dollars and cents. So let's do the problem on page 20 together, and you can see how this function comes into play. So with my fingers on home row, I'm going to go down and key in the 236. Now, I did not hit this decimal. I don't need to because I've put it in add mode. It will put that decimal in for me. And it will put it in the two positions to the right of the numbers that I keyed in because I have this set at 2. So now I'm going to press the plus. Okay, and it's not doing it. Why is it not doing it? Okay, let's try this again. Oh, you know what? I forgot to disengage the grand total function. That can happen. Okay, let's try this again. Still not working, dang it. Oh, maybe that's not set. Okay. Okay, we're starting over. Okay, forget all that I just did. Okay, take 2 on the touch addition and subtraction using the add mode. Hi students, today this lesson is going to focus on using the add mode function in conjunction with the decimal selector on your calculator. So to place your calculator in add mode, that function is over here. We want to move the selector up to the A/plus here. So that engages the add mode. And engaging the add mode is like telling the calculator, put a decimal point in this number. Setting our decimal point selector at 2 is giving it the instructions to put the decimal point 2 places to the right of whatever number we key in. So let's take a look at the demonstration problem on page 20, and let's take a look at how add mode will help us to key this problem into the 10 key. So the first number is a positive $2.36. So we key in 236 and a positive. The next is $5 even. Now I can key in a 5 and then I could press 00 with my thumb, or I could come down and use this double 0 to key that in. Then that is a positive number, so I'm going to press the plus key, and notice that the decimal is being placed properly in the problem because we have given the calculator the instruction by putting it in add mode to get a decimal point in, and in the second place by setting this decimal selector there. So the next number in the problem, $1.25, is negative number, so I'm going to key that in with the red key, minus key, then 349, 369 is a negative, 258 is a positive, and then I'm going to hit my total key. So we've keyed in this problem without having to key in the decimal, without using that decimal key on the calculator, but by putting it in add mode and by putting the decimal selector at 2. Hi students, in this video I want to talk a little bit about the importance of place value position and rounding and estimating without the calculator. While this is a great machine to help us do our business application problems, we need to test our own work for reasonableness, and one of the ways to do that is to round and estimate and get an idea of the ballpark of what your answer should be so that you can test it for reasonableness. So I would like you to turn to page 24 in your text and take a look at the place value diagram and just review place value positions. And let's talk about how that relates to rounding and estimating. For instance, if this is the number that we're wishing to round, we first need to decide to what place value are we rounding this number. If I said to you, let's round this number to the nearest 1,000. Well, this is the 1,000th place value position. So if I want to round this to the nearest 1,000, what I'm asking is it closer to 13,000 or is it closer to 14,000? Well, because this place value to the right is a 7, which is greater than 5, this would actually be closer to 14,000. Now, if instead what we're doing is we're rounding this number to the nearest hundredth, this is the place value that we're rounding. We look to the right of that and we say, is this number 5 or greater, in which case we would round up. If not, then we would round down. So is 745 closer to 700 or closer to 800? Well, I would say it would be closer to 700. So if we were rounding it to the nearest hundredth, it would become 13,700. If we're rounding, on the other hand, to the nearest tenth, then what we're saying is we would be looking at the 10th place marker, which would be not hundreds, okay, but tens. So we look to the right of that 10 and we say that's a 5. Therefore, this would need to be rounded up. So this would become 13,750 because 45 is closer to 50 than it is to 40 because we're rounding up. So that gives you a little bit of a review. The idea is that with estimating, if you round and then do an estimate, that's a problem that you can do in your head. So the idea with rounding and estimation is to test the logic of our answer, but also to get the problem to a rounded number that we can in fact deal with in our heads. If you take a look at the demonstration problem, let's see here, on page 26. Let's take a look at how we can estimate this problem. So if the problem was 4,658 times 332, that would be difficult to do in your head. So we need to simplify it, and we do that with rounding. So you round to the greatest place value. Here's the greatest place value. So is this number closer to 4,000 or is it closer to 5,000? Well, because this number is greater than 5, that's actually closer to 5,000. So basically I'm going to round that number to 5,000 to work with it. Then I look at the next number. I want to round this number to the highest place value. The highest place value is hundreds. So this number is closer to 300 than it is to 400. This tells me, because this is not a 5 or above, that I'm going to leave it at 300. Now that's much more manageable, 300 times 5,000. And I can actually make it even easier by way of saying I could cancel these zeros, and now I'm down to 5 times 3. That's something I can do in my head. 5 times 3, I know, is 15. Now all I need to do is add back those zeros that I canceled. So there are 5 zeros that I need to add. Assuming the decimal place is there, we've added 5 zeros. So that number becomes 1,500,000. That is an estimate that I can do in my head. Now let's do the actual problem. 4,658 times 332 equals 1,546,456. Now this estimate is pretty darn close to that, so I would say that's a reasonable answer. So that's a demonstration of how we can use rounding to help us estimate, and then use estimation to help us test the accuracy or reasonableness of our answers. Hello students, we are going to focus on lesson 6, multiplication, using the 10 key calculator. And you'll notice that you'll be using this plus equal key to get the answer or the product for these multiplication problems. We're going to take a look at the demonstration problem B on page 29. And I'd like to point out that if in estimation, if both factors would be rounded up, you'll end up with an answer that's closer to being accurate if in fact you round one of the factors up and one of the factors down. So let's take a look at this example. Demonstration B. 575 times 658. Well, 575 would be rounded to 600. 658, according to the regular rounding rules, would also be rounded up. But if we just round one of those factors up, the one that is closer, and we round the other factor down, then we'll end up with an answer that's a little closer to being accurate. So this estimate would become 600 times 600, or 360,000 would be our in our head kind of estimate. Then we're going to do the actual problem on the calculator. So we're going to key in 575 times 658, and we're going to press this equal key. So notice that this key provides both those functions, entering a positive number, but also the equal key to get us the answer to the multiplication problem. So the actual answer is 378,350. Our estimate of 360,000 was fairly close. So that's how we can use both estimation as well as the rounding rules to help us to test the logic and reasonableness of our answers that we come up with using the 10-key calculator. I'd also like you to take a look at the round switch. Page 30 introduces you to the round switch. That is this switch right here on the Sharp calculator. If you put it in the up position, it will round all numbers up. If you put it in the down position, it will round all numbers down. Leaving it in this 5/4 position, the round switch will then round the answer to the place set by the decimal selector. So notice that in problem D on page 31 and 26 through 34, you're instructed to set your calculator at 4, the decimal selector at 4. If you wanted to do mental rounding, if you wanted to simply set this at 3, you could do mental rounding down to 2, or you could always leave your decimal selector on float and then do the rounding mentally according to the number of decimal places that are appropriate in the problem. Anytime you see a dollar sign in a problem, that should register in your mind that you need 2 decimal places, because we don't pay in half a cent. So we always want to round anything that involves a dollar amount that equals 2 decimal places. Hello students, this video is using the invoice on page 32 to demonstrate how to do extensions, which is the terminology that we use when we take the quantity on the invoice and we multiply it times the unit price. So we're going to use the grand total key in this as well. So if you would please turn to that invoice, and we'll use it as an example. When you do the multiplication of quantity times price to get the extension, if you have the grand total function engaged, you'll be including each extension answer in the grand total. And that means that when you've completed the last extension or multiplication on the invoice, you can press the grand total key and it will add all those extensions together. So let's do this demonstration problem. We're going to engage our grand total function. We're dealing with dollars and cents, so we're going to set our decimal selector at 2. And we're going to key in the first extension. That would be a quantity of 18 times 39 point, and I did include the decimal, so 39.75 is our price, and we're going to press equals. Now that extension went into the grand total. So not only do we have it here to be able to include it on the invoice as an extended amount, but it's getting included into the total invoice price as well. We'll do the next one. 36 times 27.35 gives us an extension of 984.60, then 12 times 45.88 gives us an extension of 550.56, 25 times 9.25, an extension of 231.25, 15 times 17.36, we have $260.40, then 100 times 5.39, 539, and the last extension, 18 times 29.97. Now I'm going to hit my grand total key, and on my tape here, I now have each extended amount going into the grand total, and the grand total of that invoice is $3,820.77. So by engaging the grand total function, setting our decimal selector at 2, we've done multiplications to get our extensions, and we've gotten the grand total of that invoice at the same time. Hi students, this next lesson is going to focus on doing division using the 10 key. And it's important to note that division problems are done on the calculator by first keying in the dividend, or the number to be divided, or the top number of the fraction, and then entering it by pressing this divided by key. The second thing you would do is to enter the divisor and then press the equal key, which will compute the quotient or the answer to the division problem. So let's do the demonstration problem on page 34. We key in first the dividend, or the number to be divided, the top number or numerator of a fraction, 1,740. So we key the number in, and then by pressing this divided by sign, that enters it into the calculator and onto the tape. And then the next thing that we're going to key in is our divisor, which is 12, and we're going to press equals. That is what then will give us the answer to that division problem using the calculator. There is an error in your textbook on this page where it looks like they're having you press the plus key after keying in this first factor, and that would be incorrect. Again, we key in the first number, we press divided by. Oh my goodness, I just noticed something. You can see on this tape that I still have the grand total function engaged. Let me show you how I can tell that, and indeed I have left it on. I'm going to turn it off right now. I also have it in add mode. Darn it! One of the first things we need to do when we sit down is always to check our functions. I didn't do that today. So, how can I tell on my tape? I can see this asterisk and plus sign here. That tells me I had the grand total function engaged. I didn't need it to do this problem, so I really want to disengage any functions if I'm not using them, because there are times that it could throw your answer off if you don't. So I'm going to clear this grand total also to make it 0 so that I get that memory cleared. All right. Now I've done that. Now let's go back and let's do this demonstration problem one more time. So we key in 1740. That is our dividend. We hit divided by. That enters it into the calculator and onto the tape. The divisor of 12 is entered next, and we press equal. And that's how we do division using the 10 key. Students, in this video, I would like to show you how the place setting of your decimal can affect what you see on your display as well as your tape. So on page 35, there is a division problem that we're going to do. And first, I'm going to leave the decimal selector at float. So I'm going to take 1,891.4, divide it by 5.1875. And we're going to see what that looks like on the display. I can see all of the decimals, as many as the display will allow. So this is the decimal selector on float. I'm seeing all the decimals that are possible to see given the size of this display. Now I'm going to change my place setting, my decimal place setting down to 4, and let's see how that changes my answer. I'm going to do the same problem, but it's going to appear differently because I have set the decimal setting in a different place. So 1,891.4 divided by 5.1875, and now I'm seeing only 4 decimals. So the first setting was on float. I'm seeing all the decimals that there are in this particular answer. Here I've got it set at 4, so I'm only seeing those 4. Now when it is set at 4, it is also rounding that 4th place. So you can see that in setting your decimal, you are definitely affecting what you're seeing. Now it might be possible for me to still then round this number in my head. So if I had the decimal set here at 4, but this was an answer involving dollars and cents, I need to round that answer to 2 decimal places. So I look to the 3rd decimal spot and I see that's a 7. Therefore, this number would need to be rounded to 364.61 or 61 cents. So please pay attention to your decimal selector as you do various problems in your workbook.